Here we go. Here's your review video for this week. Remember, these IXLs, you do need to practice them tonight. All of those things are going to be on your test tomorrow, and that's the only really new practice you're going to be able to get. If you're doing this at home, you may need to Google how do you delete cookies so that it will let you keep working once it locks you out. That's the only way you're going to be able to reset so that you can move on. All right, this first problem, the directions aren't written very well, but it's just asking you to write and then give a reasonable domain. So when we write here, we're just going to be writing a general equation, f of x. It says we've got an admission fee of $9 and each ride costs $175. Each is my rate word, so I know I'm going to have $9 to get in the door plus $175 for each ride. That's 175x. Remember, it's always a good idea to say what X stands for. So X is going to stand for the number of rides. And when we say our domain, we want to talk about what are all the options. So this question kind of reads like you are going to go on 12 rides, but if there were only 12 rides to choose from, then you could, I guess, potentially go on 0. Then you wouldn't be doing much of the carnival, but you could do that. Or you could go on 1 or 2 or 3, so on, all the way until you get to 12. All right, so that's what it means to write, to pick a reasonable domain is to pick the values that would make sense for the situation. Our next two questions are asking us to write, solve, and write a sentence, which most of you in class decided it was easier to solve the question first and then go back and write the equation. So in this first one, if he worked for 4 hours, you would pay the plumber $70 per hour, so that's 70 times 4, plus $40 for the call. All right, if we worked that out, we would get, let's see, 7 times 4 is 28, so 280 plus 40, that's 320. So the solving is that f of 4 equals 320. And then the sentence, all we do there is just write a sentence that makes sense. And what that means is that for 4 hours, he charges $320. Remember, the dollar sign goes to the front. Okay, the part that most of you were struggling with maybe the very first time and you got a lot better at is when we go backwards and we try to write the general equation. And the general equation would be if we didn't know how many hours. So that would be f of x equals 70x plus 40. Notice that instead of assuming that it's 4 hours, right, I'm replacing that 4 with just an x, an unknown number of hours. So x stands for the number of hours. All right, if we look at question 7, very similar type of setup here. All right, if we do 14 garbage bags, that's going to be $4 for every garbage bag, so 4 times 14, plus $10 for the weekly fee. And that's going to give us 56 plus 10, 66. Okay, that means 14 garbage bags cost $66. This is not a great sentence. I really mean to pick up 14 garbage bags. And then remember, we go backwards. And going backwards, we're just replacing this 14, this amount that I knew, with something that I don't know. We call unknown things variables. So we've got f of x equals 4x plus 10, where x stands for the number of garbage bags. All right, evaluate each function. Some of you may have been just a little bit confused just because they're using different letters here. All of these mean the same thing as f of x. They just use different variables. I don't really know why. So all we're doing is replacing the x that we see with the value. So I've got k of 6 equals 3 times 6 squared minus 3. Remember your order of operations. All right, we've got to do parentheses before we do, and exponents before we multiply or divide. So that means this is 3 times 36 minus 3. which is going to be 108 minus 3. So my final answer is that k of 6 equals 105. You should write it using that function notation. Here we're going to evaluate at 10, so g of 10 equals negative 3 times 10 minus 1, negative 30 minus 1, negative 31. All right, we've got h of negative 6 equals, notice I'm just plugging in over and over and over again. All right, so that's negative 18 plus 2, which is negative 16. So h of negative 6 equals negative 16. And lastly, don't get tricked on this one. We're going to plug in negative 8 to both places where the variable exists. So this is negative 8 squared plus 2 times negative 8. All right, that's going to give me negative 8 squared is negative 8 times negative 8, which means I'm going to get positive 64 minus 16. And if I work that out, I should get 48 if I'm subtracting right. So g of negative 8 equals 48. Okay, this set is asking me to find the first 4 terms. That means they want to know what is f of 1, f of 2, f of 3, and f of 4. Some notation just to pay attention to. A of n means the same thing as f of n. And this a sub n minus 1 is the same thing as f of n minus 1. So this first equation really means f of n equals f of n minus 1 is the previous, so it's the previous times 2. And they're telling me my first term, f of 1, equals 1.5. So to find f of 2, I'm going to do the previous times 2. And the previous is that previous value, 1.5. When I do that, 1.5 times 2, I get 3. All right, so now I'm on to the next one. F of 3 equals the previous times 2. Well, the previous term was 3. 3 times 2 is 6. All right, f of 4 is the previous times 2. My previous term was 6, so 6 times 2 is 12. So there are my first 4. I'll highlight so we can see. These are my first 4 terms. All right, let's fix the notation here. My formula here is that f of n equals 2 plus the previous divided by 2. Okay, so I've got my first term. F of 2 equals 2 plus the previous, right, which is negative 22, divided by 2. So I'm gotta add, take care of the top part before I can do that division. So 2 plus negative 22 is negative 20, divided by 2 is negative 10. All right, f of 3 equals 2 plus the previous term, which was negative 10, divided by 2. That's going to be negative 8 divided by 2, which is negative 4. And again, we got to get 4 terms here. 2 plus the previous term, which is negative 4, divided by 2. Negative 2 divided by 2 is negative 1. So there we go. Those are my first 1, 2, 3, 4 terms. All right, these are explicit equations, which are a little bit easier to deal with because I can plug straight in. So if I want to find f of 1, all I do is plug 1 in for the variable. All right, so 23 plus 6 is going to give me negative 17. F of 2 is going to be negative 23 plus 6 times 2. All right, that's negative 23 plus 12, which is going to give me negative 11. F of 3 equals negative 23 plus 6 times 3. That's negative 23 plus 18, which is going to give me, negative 5. And then f of 4 equals negative 23 plus 6 times 4. That's negative 23 plus 24, which is going to give me positive 1. So there are my first 4 terms. Okay, this one, same idea. We can plug straight in because there's no previous. So f of 1 equals 10 to the 1 power minus 3. That's, if you don't know, 10 to the 1 power is just 10. So 10 minus 3 is 7. F of 2, 10 to the 2nd power minus 3. 10 times 10 is 100 minus 3, which is going to give me 97. F of 3, 10 to the 3rd minus 3. You may not know this, but this exponent on a 10 tells you how many zeros there are. So 10 to the 2nd gives you 2 zeros, 10 to the 1st gave you 1, 10 to the 3rd power gives you 3 zeros, 1, 2, 3. So 1,000 minus 3 is 997. And then f of 4, 10 to the 4th, right? That's going to give me 4 zeros, which is going to be 9,997. And there are my first 4 terms. All right, so explicit, remember, are easy to work with. If they want us to find the 29th term, that's very simple. I can just plug 29 in. So I'm going to find f of 29 equals 192 minus 200 times 29. All right, that's going to be 192 minus 5,800. And then that's going to give me negative 4,608. All right, I'm doing that without a calculator, so let me check myself real quick. Oh, I'm glad I checked. Okay, that should be 5,000, not 4,000. Negative 5,608. All right, so that's going to be your 29th term. All right, so this question is kind of asking backwards. It's saying, what term is 63? So it's that same question of like, you've got a list of terms and somewhere in there is 63. Where is that in the list? So when that happens, we don't plug in for n. Instead, we set our equation equal to that value. So 63 equals negative 11 plus 2n. And then you just solve like normal. Add 11, 74 equals 2n. Divide by 2. And that's going to give me n equals, let's see, 35, 37. So that would mean f of 37 equals 63. Or you could say the 37th term. Either way, you're indicating that the 37th term is the one that is 63. Okay, remember here when we're graphing, if they give us a certain domain, my final answer is going to be discrete. All right, we're not going to connect the points. So this is y equals 3 x minus 2. And actually, here I'll make our little table, get a little organized for us. They give me the x values negative 3, 1, and 5. So I need to plug those in each. So this is y equals 3 times negative 3 minus 2. Negative 9 minus 2 is negative 11. So my first point I'm going to plot is negative 3, negative 11. And I'll go ahead and plot that. Make sure you pay attention to what it's counting by. All right, there's negative 3, negative 11. And then we'll switch over. Now we're going to do 1. Y equals 3 times 1. All I'm doing is plugging in for the x spot. I'm taking each of these and I'm just plugging the values into the x spot over and over and over again. 3 minus 2 is 1, so 1, 1. All right, that's going to be right here. And then lastly, we're going to do 5. Y equals 3 times 5. Minus 2 is 15, minus 2 is 13. So 5 and 13, which looks like it's going to go off of our graph, but that's okay. We'll just make it as close as we can. We'll just put it kind of up here off our graph. Remember, we don't want to connect. We want to leave those as separate points. All right, 19, again, we're going to leave it unconnected because they give us the specific domain. But remember, it's going to be easier to plug these things in for x if y is already by itself. So the first thing I'm going to do is isolate the variable y. I'm going to do that by moving this 2x to the other side. So it's going to be y equals negative 2x plus 12. And now I'm going to make my table using my x values 2, 3, and 4. All right, we'll do our first one. Y equals -2 times 2 plus 12. That's -4 plus 12, which is going to give me 8. So 2, 8 is my first point. All right, this one's a little nicer to graph because it's actually on the grid. Y equals, now I'm going to plug in 3. -2 times 3 plus 12 is -6, which is 6. So I've got 3, 6, 3, and 6. And then 4 is the last value they're going to have me plug in. Y equals -2 times 4 plus 12. That's -8 plus 12, which is +4. So 4, 4. And because my domain is separate, because they give me separate values, I leave this unconnected because this is discrete. All right, 2 things to notice about question 20. One is that they don't give me a domain, which means my domain is all real numbers, and that I'm going to have a continuous graph. Also, you may notice that y is not by itself, so I've got to fix that first just to make it easier on myself. 3x minus 3y equals 9. I'm trying to isolate y, so I'm going to move 3x to the other side. -3y equals -3x plus 9. Divide by -3, so y is going to be x minus 3. And then this is the equation I want to use to make my table. And because they give us all real numbers, you can pick any values that you want to. I would say try to pick values, a few negatives, a 0, and a few positives. So we'll do -2, 0, 2, and 4. So with -2, that's y equals -2 minus 3, -5. So -2, -5. And I'll go ahead and plot that. -2, -5 is down here. All right, if I do 0, y equals 0 minus 3, which is -3. 0, -3. 2 is going to give me y equals 2 minus 3. That's going to give me -1. So I've got 2, -1. And then lastly, oh, I already drew mine. Lastly, I'm going to do y equals 4 minus 3, -1. Oh, +1. All right, so 4, 1 is my last. And then remember, this is continuous, so I do want to connect my points. And I'm actually, because it's supposed to be continuous, you need to make your arrow and your line or curve or whatever it looks like, try to make it go all the way through the graph so that you indicate that it's going to go on forever and ever. Okay, so this last page is just about interpreting graphs. So if we kind of refer to this graph on the far right side, there are a few different things happening. There's 3 or 4 sections here. A is obviously an increase in rain. B is also an increase in rain, but it's going to look a little different. C, notice that time is not really changing very much, but the rainfall is increasing dramatically. So that's almost like an instant change in rain. Think about like a very serious downpour. And then D, the amount of rain is not changing. So on D, it's 7 inches, except time is moving forward. So if there's no change in the amount of rain, but time keeps passing, that must mean it's not raining. So what does segment D represent? Segment D would be it not raining, or there's no more additional rain. All right, which segment represents the heaviest downfall? Well, A is a pretty heavy downpour because it's steeper. B is going to be increased also, but C is, like I said, that's almost instantaneous. So if hardly any time is passing and it's that much of a jump, I would say C is going to be the heaviest rainfall. It's going to be like an instant downpour. Think about when it's like whiteout conditions because it's raining so hard. All right, the next set of questions is asking us, would it be a better continuous or discrete graph? So let's look at those. So you want to think to yourself, discrete would be like, are you trying to count individual data points versus continuous where what you're thinking about would apply at all points in time or for all values. So the number of cans collected for recycling, you could have like 1, 2, 3, however many cans, but you couldn't collect anything in between like 2 and 3. You couldn't collect part of a can. So that is an example of something that would be discrete because you have to have individual data points. All right, pouring a glass of milk, if we're thinking about like the amount, that's not really worded very well, but if you're thinking about the amount of milk, that's changing continually. All right, you don't pour just like one instant glass of milk. You could have a half a glass of milk or anything in between. So that would be an example of something that's continuous. The distance a car travels from a garage, again, you could measure that in a number of different ways. It's not like when a car travels, it only goes 1 mile and then the next distance is 2 miles. You could go 1.1, 1.2, however much. So this would again be an example of continuous. The number of people in a restaurant, all right, you can't have part of a person. When you count people in a restaurant, you've got 1, 2, 3, 4. You have to like count them individually. So again, that's an example of something that would be discrete. All right, our last problem, woohoo, is to match the graph with the situation, define the type of graph, so is it continuous or discrete, and name the domain and range. So Jason takes a shower, but the drain in the shower is not working properly. So the depth of the water. So the depth of the water is going to increase, and you might have individual data points, but an example like A would mean that in 1.5 minutes, there's no water to be found in the shower. That would, I can't even really think of how to explain that, but that doesn't make any sense. Like there's always going to be some water in the shower, and that's going to be a gradual increase or decrease. So it's not going to be A. So that means to answer the second question, the type of graph it's going to be is continuous. And C would imply that the depth of water is 3 inches the entire time. All right, that might be if he was taking a bath, albeit a weird bath because you need to have more than 3 inches. But that would mean that the water depth never changes. But we need the water depth to change because even if it's not draining properly, you should still start at 0 and then increase. And then this decrease would obviously be him getting out of the shower and the water starting to drain. So the correct answer for the graph would be B. And then the domain and range part, we're kind of going to leave that up in the air, but domain, I just want you to realize that the domain is going to be between 0 and 8. So I'll go ahead and show you that's what this looks like. Don't stress about knowing that, but just know that's what it's going to look like. And then the range, it looks like the highest the water ever gets is 2. So the range is going to be between y is between 0 and 2. Again, don't stress too much about the domain and range. As long as you know domain is X and range is Y, you're going to be okay for your test tomorrow. All right, here we go. Here's our review for week 2. Fast forward, watch what you need to watch. If watching does not help you, you need to come to tutoring tomorrow so that you can get some extra help and ask some specific questions before we start your test. All right, we talked a little bit about this first section today during class. I did an example with you. So remember, arithmetic is when you add or subtract. Geometric is when you multiply. So on this first example, when I look at that, and you should look at these before you watch what I'm doing, we're adding 8 every single time, so that's going to be arithmetic. Question 2 is not adding. It looks like it's multiplying by 6. So if it's multiplication, that's going to make this one geometric. It looks like number 3 is pretty similar. We're multiplying by 6, so that's geometric again. Number 4 is not multiplying by anything, like that's times 9, but 9 times 9 is certainly not 25. And you could try plus 8, but 9 plus 8 is also not 25. So that means this one is neither. On this bottom set, we said geometric. You either are looking for something that's going to multiply or you're looking for an exponent. So for example, 5 has the exponent, so it's geometric. Number 8 has an exponent, so it's geometric. Number 11 is multiplying, so it's geometric. Which means since your only other option is arithmetic, that means everything else here is going to be arithmetic. Specifically, you should notice that 9, 10, and 12 are arithmetic because it says they're adding as the pattern. All right, we talked about question 13 in class. Remember, you want to look at the starting point and then try to figure out, first of all, is it getting bigger or smaller? So bigger is going to mean your pattern needs to be a multiplication pattern. Smaller would be division. And then we can figure out how to check that pattern. So I know it's definitely not starting at 4 or 5. So B and C are both wrong. And then if I pick 2 points, so like this point is at 1, if I look at my Y value. And then my next point is at 2 on the Y value. And then here I've got a point at 4. And again at 8. So think about that. 1, 2, 4, 8. That's multiplying by 2 every time. So the correct answer here is D. Okay, question 14 here is very similar. We're looking at the starting point. So it looks like that starting point is a fraction. So I can kind of go ahead and eliminate all the rest of those because the others start at 3, which is not true, 5, not true, and 7, not true. And then if I just pick some points here, all right, I've got a point that's somewhere around 2 and somewhere around 14. And since I'm going from 2 to 14, that's times 7, which is exactly what this pattern says. So that means B is going to be the best option. All right, 15 and 16 here, very similar to 13 and 14. My starting point is 3. So that's instantly going to tell me that the answer should probably be C. But we can check also the pattern. If I have 3, this would be that my pattern is multiply by 2. So I just want to check that that's true. So if I start at 3 and I multiply by 2, yep, that gives me 6. And if I multiply by 2 again, that gives me 12. All right, so that one makes sense. That's a good fit. 16, all right, looks like I've got a fraction here as the starting point. So the starting point is not 2 or 4. And it looks like both of these indicate that we're getting smaller. A is divide by 2, and B, the pattern is divide by 6. So we want to pick some points that it's kind of easy to check how is this being divided. So I'm trying to find points that go through corners. All right, so to me, those are my points. I've got a 3 and a 6. So if you're going from 6 to 3, if those are your values, is your pattern here divide by 2 or divide by 6? And hopefully you agree that it's divide by 2, which means A should be my answer. Okay, common ratio from last week, same concept, is just what's the pattern. And here my pattern is multiply by -4. So we can say times -4. And to find the next 3 terms, you simply just continue the pattern. And when you do that, you should get -768, 3,072, and -12,288. 18, we want to map the pattern. It looks like here we are multiplying by 2. It's positive 2 this time because the signs aren't changing, so multiply by 2. And then to continue that pattern, I'm going to get -64, -128, and -256. All right, 19 and 20. We did one of these in class today. So you all said you like the table the best. So I'm going to go ahead and enter and say that my 6th term is 32. And R equals 2 means my pattern going forward is to multiply by 2, and going backwards is to divide by 2. And the question, if you read the directions, the question is asking for the 8th term. So I've got to go forward so I can get to 8. So if I multiply by 2, that's going to give me 64 and 128. So the answer to this question then is 128. All right, like we did in class today, I'm going to make my table again. My 6th term is, I didn't leave myself enough room there. My 6th term is -7776 To go forward, they're telling me my pattern is to multiply by 6, and going backwards, my pattern is divide. But since I need to find my 8th term, I'm going to have to go forward. And that is going to give me, we got some really big numbers going on, negative 46,656. If I do that again, I get negative 279,936. So there's my final answer. Okay, here they're asking us to write the explicit and the recursive formula. So explicit, remember, well, actually, before we even do this, we need to find the pattern and the starting point. So remember our pattern here, if you go ahead and work that out, so take a second to try that. Our pattern is going to be divide by 5, and the better way to write division is a fraction. So remember the pattern then is multiply by 1/5. So when I go to write, oh, I keep interrupting myself. I also have to find the starting point. And remember, mathematicians start at 0, so you got to go the other direction to find that. So instead of divide by 5, I'm going to multiply by 5, which is going to give me 31,250. So now my explicit puts everything into one equation. So my explicit is going to be f of x equals my starting point, 31,250, times 1/5 to the n power. Remember, you got to put the pattern with the exponent. My recursive formula does two separate parts. First, it tells me the starting point, f of 0, and then it tells me the other equation, which is f of n equals f of n minus 1, and then the pattern times 1/5. There's not a whole lot of mystery here. You just kind of have to memorize the pattern or the format of how you put these equations together. All right, while I'm here, I'm going to go ahead and go over 23. So again, we need to figure out what's our pattern. And here it looks like we're getting bigger, I guess, times 3 going forward. And then I need to find my first value. So I'm going to divide by 3, which is going to give us negative 2/3, since that doesn't divide very well. All right, so now we're going to write. I've got my explicit equation, which puts everything in 1. F of x equals my starting point, negative 2/3. Probably good to put that in parentheses just since it's a fraction. And then my pattern going forward is times 3 to the n, or to the x, either way. I should probably put x just to keep the same format. And then recursive is going to be, I got to say my starting point on its own, f of 0 equals negative 2/3. And then I also list my rule, f of n equals f of n minus 1. This time my pattern is times 3, so times 3. Notice that all the recursive does is it just splits it into two different things, the starting point and the pattern, where explicit puts them both in the same equation. All right, I'm not going to go over 23 because we did that one in class together. So 24, if I go forward, I notice my pattern is multiplying. It's multiplying by 5, but really multiplying by negative 5, because notice that the signs are changing. So to go backwards, I'm going to have to divide by negative 5, which is going to give me a starting point of negative 2/5. So I've got explicit f of x equals my starting value, negative 2/5, times my pattern, negative 5 to the x power. And then recursive just lists the two parts separately. The starting point, f of 0, is negative 2/5, and the pattern, f of n equals f of n minus 1 times negative 5. All right, 25 is a review from last week. Remember, you're just going to have to break down what's inside there. So if I do my factor tree for 48, all right, that's what I've got. So I'm going to get the cube root, 2 times 2 times 2 times 2 times 3. I'm going to list out all my variables. And remember, the number in the corner tells me how many things I need to make a group. So I've got a group of 2's, a group of x's, and another group of y's. All of those are going to come out as whole numbers. So I'm going to have 2xy on the outside, the cube root of 2 times 3 times y on the inside. And if you look at our answer choices to find the one that is going to match that, D matches, and all they've done there is multiply that 2 and the 3, put it back together to make a 6. Since it can't make a group, you can go ahead and put it back together. That's how they're getting that. All right, again, to start this problem, you need to make a factor tree and break everything down. All right, when I do that, I get the square root of 2 times 2 times 3 times 3 times 5, and there should be 4 k's on the inside. And then square root has a secret little 2 here in the corner. That means I need groups of 2 to make whole numbers. So I've got a 2, a 3, a k, and a k. That's 2 times 3 times k times k. A square root 5 left over. And the answer choice that's going to match that is going to be B. All right, the 6 comes from 2 times 3, and they just put these k's back together to make k squared so that it looks a little simpler in your answer. All right, I'll do 27 and 29 together. Remember that negative exponents mean reciprocals, so these things need to move down. So when I rewrite that, if all of these are going to reciprocal, I've got 2 that's staying on the top, a y to the 1, x 2, y 2. And then you can expand that out if you need to, but hopefully you see these y's are going to go together on the bottom. So I'm going to have x to the second power and y total. That's going to be 1, 2, 3. So y to the third. All right, 29 is parentheses to the 4th power. That means I've got 4 parentheses with all of that in it. So that means I'm going to have 4x to the 3rd, y to the 4th. And then now we're just counting up. So all of these 4's, that becomes 4 times 4 times 4 times 4, which is 256. And then I've got 1, 2, 3 x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's, x to the 12th. And then for my y's, I've got 4, 8, 12, 16. I'm just counting up, so that's 16 y's, y to the 16th. All right, 28, again, negative exponents. Whoa, negative exponents mean reciprocals. So when I rewrite this, I'm going to have 2, and I'll go ahead and spread this out. X to the 4th, x times y, 2, 3, 4 times a 3. Let's see, and we need to squeeze another x on the top. The only thing that's going to move to the bottom is this y to the negative 2, and that's going to become 2 y's on the bottom. And now I just want to cancel. So I've got these y's that cancel. When I put everything back together, I have 2 times 3, which is 6. And then if I count my x's up, I've got 1, 2, 3, 4, 5 x's. That's x to the 5th. And let's count our y's. 2 y's left on the top, which is going to be y squared. So there's my final answer. On question 30, the only thing that should stand out to you as being a little strange is this a to the 0, which is just a 1. So I've got 4 times b over 2 times 1 times b to the 3rd. And I'll even spread that out again. 4 times b, 2 times 1 times b times b times b. I've got a pair of b's that cancel. And then we want to treat this fraction as something that could simplify, and 4 over 2 can become 2 over 1. So this is now 2 over 1 times b times b. And the simplest way to write that is 2 over b squared. All right, 31. We've got a negative that's going to need to be a reciprocal. Since it's on the bottom, it's going to move to the top. So I've got 4x times y, and then I'm moving those x's to the top with that. A 2 on the bottom. So my 4 and my 2, I can reduce that to be 2 over 1. So that's 2 over 1. And when I count my x's, I have 1, 2, 3. That's x to the third, y squared. And you can leave that as a fraction over 1 like that, or you can simply just write the numerator on its own. So if the 1's on the bottom, you don't necessarily need it. But if you want to be careful, if you want to be safe, you can always write it as a fraction. We're almost there. All right, 32. So they give me the starting point and the pattern. And so we're just going to make ourselves our table. Remember, starting is 0. And then you just decide which direction makes the most sense to go. So forward is going to be times 2 here. Backwards is going to be divided by 2. So which one is going to give us better numbers? Well, we should do at least 1 in both directions. So if I go backwards, that gives me the decimal 0.6. If I go forwards, though, I start to get better numbers. 2 times 3 is, 2 times 3 is 6, 12, 24, 1, 2, 3. And then you just want to take those points and get them onto the graph. You should have points that look something like that. And you do want to kind of make your line look a little bit curved. We'll talk a little bit more about that again next week. All right, same thing on 33. We need to make our table first. Put 0 in the middle. So our starting point is -4. Our pattern is to multiply by 2 going forward and divide by 2 going backwards. And you really just need to do as many points as you can fit until they start getting really difficult to graph. So if I go backwards, that gives me -2. -2 divided by 2 is -1. -1/2. So once I'm hitting a decimal, I'm going to stop. And then I can go forward, -8, -16, -32. And then we would just want to fit as many of these as we can on our graph. So 0 is -4. I'm going to pause and go ahead and plot the points for us. All right, and that's what my graph is going to look like then. You might think 34 is a little odd because it doesn't look like they give us, it's hard to tell if they give us a starting point or a pattern. But remember, the number with the variable is the pattern. So here's my pattern. And we need to have a starting point. So the starting point is going to be 1 because we got to pick something that we can multiply by. If you picked 0, think about anything times 0 is just 0. So you wouldn't actually ever get a pattern going on. So going forward is times 2. Backwards is divide by 2. So I could go backwards 1 time and I'll get 0.5 or 1/2. If I go forwards then, I'm going to get 2, 4, 8, 16, and that's as much room as I have for on the graph. So we're just going to plot those points. 1, 2, 4, 8, 16, and then go backwards. And we've got this curve that looks like this. Last question. Hallelujah. All right. Starting point. Starting point is 4. And then 1/2 is my pattern, which means my pattern is really to divide by 2. So going forward, it's divide by 2. And then going backwards, it's multiply by 2. So I'll go forwards for as long as I can. 2, 1, 1/2. Once I hit the fraction of the decimal, I'm going to stop. Then I'm going to go backwards, multiply by 2, 8 and 16. All right, so when we graph this one, remember divide by 2 means it should get smaller, so we just want to check that when we look at it, it does indeed look smaller. And to me, that does look like it's going to be getting smaller from left to right, right? If I draw my line here, we're definitely getting smaller there. Again, remember, if you need any help, you need to make sure you come to tutoring so I can give you some specific help on the questions before we take your test tomorrow.